This example is going to represent a particularly problematic credit card situation, so let's check it out. What I'm doing here is I'm imagining someone who runs up $5,000 on a credit card. I'm imagining a college student, freshman, gets in there, right? Gets a credit card offer. They used to give these on campus, these credit card offers at 29% APR. So it's a 29% interest rate. Say as a student gets this $5,000 limit and runs it up instantly, and then refuses to make any payments for 5 years. Just I can't, students in college can't think about it, puts it away, and then goes to 4 years of college, 1 year to get a job, and 5 years later, suddenly he's ready to make some payments. So how much will he owe if he ran up $5,000, 29% APR, compounded monthly for 5 years? Okay, that's the question. We use this interest formula, A equals P times quantity 1 plus R over N, all to the power of NT. What in the world do these variables mean? Well, here they are. A is amount. That's the amount now, the amount currently owed. P is for principal. Principal, right? P-A-L, not P-L-E. We're not talking about principals here. We're talking about the principal with an A. That's the initial amount. Okay, so, right, so this would be the 5,000 in this case. It's the initial amount spent. Let's see here. N is the number of times per year compounded. How about I'll say number of times compounded per year. All right, and R is the rate. Draw enough arrows here. Rate, and T is the time. Let's see, and when I say this, number of times compounded per year, what does that mean? Well, when you have a debt, for instance, they compute your interest, and then they take that interest and they put it back into your account as principal. You could think of it that way. So every time they compound it, they take the fraction of the interest and they charge you that and put it back into your account, and then you charge you interest on the interest, right? So this can happen, once a year, it can happen twice a year, it can happen once a month, once a day, 4 times a year. So here's a summary of the different N values. If it's compounded annually, we have N equals 1, semi-annually, N equals 2, quarterly, N equals 4, right? How many times a year is it done? If it's compounded every month, well, there's 12 months in a year, so N equals 12. Weekly, 52 weeks in a year, N equals 52, daily, 365, etc. You can compound it every minute, every second, even every instant, but that's going to be a different formula. We'll talk about that later. Okay, so here's all our stuff. So let's use it on this poor college student situation here. See what we get. Okay, so the amount, that's what we're trying to compute. The principal, 5,000. Okay, 1 plus the rate. Well, the rate is 29. Hold on here. Rate is in decimal form, by the way. So what I mean by decimal form, move the decimal 2 places to the left. Right, so we don't say 29%, we use 0.29. So go back and review all your decimal percentage stuff if you don't remember why that's the case. So 0.29 goes there. N, okay, this is compounded monthly, so N is going to be 12 for monthly to the power of NT, so 12 times T, 5 years. 5 years, and this time is the number of years. The time matches this APR. This tells us this compounded is 29% interest per year, is annual percentage rate. So in all the examples we'll see, this time is going to be in years. Even though the number of times compounded is months, we don't have to somehow compute the time that the loan is active into months or anything. This is going to be years. So I'm just going to say years for now with these kinds of interest problems. Okay, so let's compute this all into a calculator. So here's where you really have to know how to use your calculator, right? What I would do here on mine, which is a TI, standard TI scientific calculator, something like this, 5,000 times, okay, parentheses, 1 plus 0.29 divided by 12, close parentheses, and then I'm going to use my caret button, which tells me we're going to the power, and then I'm going to do parentheses 12 times 5, close parentheses. A lot of people forget to put these parentheses when they do the power. If you forget that, what you're really doing is multiplying the whole thing at the end by 5 instead of keeping that 5 in the exponent. So when you do the power of, you want to put these whole things, both of these in parentheses here. Okay, let's see what we get. Typing it in gives $20,951.17 if we round to the nearest cent, which is the nearest hundredths of a place. And you pretty much always do that with money. Okay, so that's pretty amazing, right? The student, right, ran up the $5,000, waited a little while, went to pay it. Now the student, without spending a penny more than $5,000, owes we should put a dollar sign here, $20,951.17. So this is how people get into credit card problems, right? Now, it wouldn't really be allowed to go this extreme. I mean, it could, in a lot of ways, it could get worse, especially if you consider payday loans. Payday loans are way, way worse than this. But you know, a credit card company would take some kind of action before just letting it sit for 5 years. But at least this gives you an idea of the what happens with compound interest. It really adds up, and it can be quite damaging if you're not careful.